Did you know that they sometimes hold robotics competitions here at the Region 10 Education Service Center?
Really?
Yeah. If you look closely at the floor, you can even see some of the markings and stuff the robots use to help orient themselves as they move. You know, like various things that their programming tells them to respond to. The same way that you might orient yourself around your school by where the cafeteria is.
Wow. I never thought much about how robots interpret things around them. I just assumed it was similar to how we all do. How do computers think?
You weren't exactly wrong. People are the ones doing the programming for computers, so we tend to model them after the way we do things. The difference is that computers, whether they're a robot, a smartphone, or even an ancient clock, can only apply predetermined or already planned actions to incoming info. That's what programming really is, coming up with what the program should do when it encounters a specific thing. Like when Spotify knows what song to play when you ask it. It takes the request, interprets it, and gives you a result. Some programming involves more steps than others. Spotify's definitely a bit more advanced than a set of gears, but it's all the same basic principle.
So a program takes some sort of information, the input, and does a predetermined something to it, resulting in the output.
Right. While we aren't restricted to it, people can do that too. We do it every day, in fact. From calculating the right ratio of sugar to iced tea, to figuring out how long it will take to finish your homework, to simply talking with your friends, we all use computational thinking, computing a result based on the information we're able to gather. The trick is figuring out how to arrange that info, that data.
So it's not just computer thinking, it's human thinking. I think I understand. Do you have something I could try?
Sure. I mentioned figuring out what an object is based on its data. If I said that I was thinking about something larger than a cat, could you figure out what it was?
That could be nearly anything. It could even be a slightly larger cat.
True. Let's add another piece of data. This thing has a trunk.
Oh, an elephant then. Or maybe a car.
Not quite. Let's add some more data. I can see it from this lobby. It's alive and it has leaves. Take all that data and see if you can compute an answer, category by category.
Got it. It's gotta be the tree outside.
Right. It's pretty simple to use computational thinking to figure out what something is when you start listing the categories it falls under.
What about arranging the data in a different way? Like for some sort of process, an action instead of an object, like washing your hands.
That works too. We can try thinking about it in a bunch of different ways, like a set of instructions. Step 1, go to the sink. Step 2, get some soap on your hands. Step 3, add water. Step 4, run water from faucet on your hands. Step 5, dry your hands on your pants. You get the idea. It's a handy way to think about things we do and to easily communicate to other people too. Click on the free-to-use sample student worksheets included in the text describing this walk-STEM stop. We've got an example of the process of brushing your teeth and different ways you can think computationally about that. Also, some accompanying pictures and flowcharts in the photo tab. Computational thinking is a simple way of describing objects or breaking down tasks, which makes them great for computers. Just for fun, take a look at anything you see here in the lobby area and try to use computational thinking to describe it. You can check out some of the ways that Dr. Fishwick from UT Dallas and his students described part of the campus using this completely jargon-free style of computational thinking. It's fun, it's simple, and it's powerful. Just click on the URL on the screen to view.
Next time I'm overwhelmed by something, maybe I'll try to take a step back and think about it computationally. Thanks for explaining it all.